Hey folks, welcome to NASA Launchpad. I'm Vince Whitfield, let's get started. What do you know about neon signs? You see them almost everywhere these days, letting you know what's open, what's being sold, how to get in, how to get out. Well, you get the idea. So we've all seen them, but do you know how they work? There's actually a very simple scientific explanation behind the neon sign. All you need is a glass tube that is filled with the gas neon. Then you run an electrical current through the tube and the neon glows a bright, beautiful orange. Done. The electrons in the gas atoms absorb the electrical energy and release it as photons of light, and different gases create different colours. The gas argon will give off a purple colour when electrified. By combining different gases with special tints and coatings on the glass tubes, a range of more than 50 brilliant colours can be made. But other than looking cool, what do neon signs have to do with NASA? Well, you see, the light that an object emits can tell you a lot about its composition. Let's check in with Dr. Richard Biles to see an experiment that will give us a little insight into these glowing gases.
One of the things that we have here are tubes of gas. And these tubes of gas, when electrified, will give off an elemental color for that element that's in there. Now this one would be an unknown, but we also have some known gases here. Blue is certainly oxygen. This would be important for planet finding. If we found a planet revolving another star and we had a telescope good enough to pull it in, we could see if the atmosphere was giving off oxygen. And then we have another gas. This is one of the noble gases called argon, and you can see it glows in a very nice purple range. And neon, which we use in a lot of signs, which is very bright orange. And you'll see this in a lot of signage around, neon signs. All these signs that glow with electricity have different elements or different gases in them, and those gases then emit that color. So if you see multicolors, maybe you can tell what they are.
Okay, so it's pretty easy to identify the light in those glowing tubes of heated gases. But how do scientists and astronomers use that same principle to identify the elements in a distant planet or star? Let's back it up a bit and review what we know about light. Meet the electromagnetic spectrum. On it, you will find all different types of radiation that travel in waves. These are the waves that scientists and astronomers measure from objects in space. You're probably most familiar with the visible light. This is a small part of the spectrum that we can see with our own eyes. But there are many other kinds of radiation that we can't see with our eyes. Things like microwaves, X-rays, and gamma rays, which are all types of energy that travel in waves, just like visible light, but their wavelengths aren't detectable with the human eye. But science has a solution for this, the spectrograph. What's a spectrograph? Good question. A spectrograph, which is also called a spectroscope, is a device that takes the light an object emits and breaks it up into its component wavelengths. You may have done the same kind of thing with visible light, simply using a prism. Spectrographs use either special prisms or diffraction grating, which bend and spread out the waves. The image that is produced is a series of unique lines called emission lines. Each element has its own unique spectral signature. Each element in the periodic table can appear in a gaseous form and will produce a series of bright emission lines unique to that element. Okay, so how can scientists and astronomers actually figure out what a star or planet in space is made of? Scientists can study the emission lines and determine what elements are present. But space is far from empty. There are gases and dust between the stars. When a hot object like a star is viewed through a cool gas, the gas absorbs some of the bands of the emission spectrum. Scientists can use the dark bands, or absorption lines, to identify the absorbed wavelengths. On Mars, for example, scientists have used spectroscopy to determine the presence of methane on the red planet. In stars, many elements may be present. Using the science of spectroscopy, astronomers can determine not only the element, but the temperature and intensity of elements in the star. NASA puts spectrographs on many of its remote sensing satellites. The Cosmic Origin spectrograph on board the Hubble Space Telescope breaks ultraviolet light into components that can be studied in detail. The Space Telescope Imaging Spectrograph, also on board Hubble, acts like a prism, separating light into its component colours, so scientists can study the composition of galaxies, the atmosphere of planets, or faraway stars. And there you go. NASA telescopes like Chandra, Spitzer and Hubble have been using the science of spectroscopy to fascinate humans and keep us learning for years. I mean, just look at some of the pictures that these telescopes have captured. and recent NASA missions like the Lunar Reconnaissance Orbiter or future missions like the James Webb Telescope will continue to use spectroscopy to help scientists expand their exploration of the universe. Pretty cool, huh? If you like those pictures, just wait, because over the next few years NASA has some brand new, top-of-the-line scientific instruments heading into space. Well, I'm out of here, I'm Vince Whitfield, and thanks for watching NASA Launchpad.